Introduction to matrices. What's a matrix? Matrix is basically a rectangular array of numbers. And what I mean by array is it's got rows and columns here. And as you can see here, I've got rows, and those go from left to right, and columns go from up to down. The way you remember rows is you have rows of seats, like in a stadium, like this. They sit row one, row two, row three. And then columns hold things up, kind of like Roman columns at the Parthenon. Doing a bad example of drawing a column here. So columns go up and down. That's how I remember it. And rows is where you sit. So you can have anything within a matrix. You have letters, numbers, variables. And as you can see, I have in this first row matrices, I have numbers. Here I have letters. It can have combinations of numbers, letters, and it even has some irrational functions here, such as 2i. I have a sigma, and even a pi right here. Now, this is an m by n matrix at the bottom. All matrices are m by n. M is number of rows. And see right here, I've got 3 rows, 1, 2, 3. And then I got 3 columns, 1, 2, 3 columns. And n is for columns, m is for rows. So m by n means, 3 by 3 means it has 3 rows, 3 columns. Now, if I look at the dimensions here on these 4 matrices, I go by rows first and columns. This is M, and this is N. And I have, in this first one, 1, 2, 3 rows, and 1, 2, 3, 4, 5, 6. So this is a 3 by 6 matrix. The next one here, it doesn't matter if it's letters, numbers, variables, irrational functions, you have shapes technically. This has 1, 2 rows and 1, 2, 3, 4 columns. So this m by m is 2 by 4. This third one here is 1, 2, 3, 4, 5 rows, just circled right here, by 1, 2 columns. And this last one is a 3 rows and 2 columns. So it's a 3 by 2 matrix. Now we can further define each component within a matrix. When we talk about the first row, this is an element. It's the first element in the row. This is the second row. This is the second element. So 2 is the first row here, 5 is the second in the row as an element. And there's 6 elements total. We can have a row vector, which is basically just going across, and has a row of 1 row by 3. We have a column vector, which is just 1 column, and this is a 3 by 1. Square matrix has an equal number of rows and columns, where m equals n. This is a 2 row by 2 columns, so it's a 2 by 2 matrix. And this is a 3 by 3, 3 rows, 3 columns, 3 by 3 matrix. Now, define overall our matrices here. Let's take a look at this. This is a square matrix. It's because it's got 1, 2, 3 rows and 1, 2, 3 columns. As I said earlier, a square matrix has m equals n, similar rows and columns. This is a columnar matrix, has only 1 column, has 3 rows here, but because it only has 1 column, it's a columnar matrix. Here's another square matrix. This is 2 by 2. 1, 2 rows. I'm sorry. Yeah, and 1, 2 columns. Here's a row matrix. And we can also call these vectors, by the way, as we learned yesterday. Here's a row vector. This is 9, 2, 4. And I should let you know that when we talk about these vectors, these are actually given when we have row 3 elements. It's usually to define the x, y, and z coordinates on 3-dimensional space. Now, when we define the element specifically, let's suppose this column G, and this is a 3 by 3. You got 3 rows and 3 columns here. If I'm talking about element 2 comma 1, this is again the rows followed by the columns. Second row, first column. There's only one thing here, and that is 18. So G 2 comma 1 is 18. And if I look at, let's look at here some examples here. 4 matrices. I got 3 by 3 right here. 3 rows, 3 columns. A3, 3. Here's the third row. Here's the third column. A3 comma 3 is 9. Let's look at D2 comma 7. The 2 refers to the second row, and it's the seventh column. 1, 2, 3, 4, 5, 6, 7. So D2 comma 7 is I. So right here. X1 comma 4, this is looks like it's a 3 by 5 matrix. 3 rows, 5 columns. And it's first row right here. So it's along this first row here. And then it says fourth column. So right here. So X1 comma 4 is 1. And this last one here, I've got a 5 by 3 matrix, 5 rows, 3 columns. And looking at the fourth row, second column. So here's my fourth row. Here's my second column right here. And that is 63. Now, simple equation here. Matrix C is a 2 by 3 matrix with C comma 1 dash equals 6. I can already tell you um, I'm looking for a 2 by 3 matrix. So it's not this one. That's a 2 by 2. This is a 3 by 3. This is a 3 by 2. The only one left is this one. But let's see if I have 1 comma 2 equals 6. First row, second column. Well, I guess it looks like none of them are actually, because matrix C is 2 by 3 matrix, 2 rows, 3 columns, and the closest I have to C1, 2 is actually 7. But let's see what C1, 2 are in all of these. Let me erase this first. So I'm looking at this first one, C1, 2, first row, second column, is 5, which is I've written right here. First row, second column is 2. On this one, I've written right there. First row, second column is 6. And then first row, second column in this one is 7.